I'm not supposed to hit refresh, but it won't do anything. thinking I'm going to close it. Connor, don't forget to change your name if you're remote, to say remote for me. Sorry, none of you guys, the person that's online. You're all here. But I can't do attendance to log that back. Oh, yay! It loaded. Sort of. So Connor. And Will back there. I think. No, doors. That's all. Okay, I think I got everybody. Let's see. In Discord last week, I posted our syllabus addendum. So let's take a look at that. And I think it was after our class last time. So you may have seen it, but you may not have. So I wanted to make sure. What he did is just revised a few things based on what we've been experiencing and our COVID stuff. I think I showed it to you guys already. But I'm just going to double check. Sometimes I never remember. How weird is that? Now, remember, if you're not here, you can use the Zoom. If you use the Zoom, please make sure you add -remote to your name so that I can get you logged for attendance appropriately. And your team members know that you're not here so they can find your name and know where you are. Notify me by email when your pattern changes. Like if you've been coming to class, but you're gonna start using Zoom. So if you notice, I would like it to be a pattern, not just a once in a while, but you know, we could accommodate that too. The big thing to remember is try to be prompt. Remember, it's not gonna be the same using Zoom as it is here. So it will be a little bit of a problem for you, but not bad. Last time, we got a collab and we got some stuff done. It's pretty exciting. So I'm looking at our collab notebook for that salesperson commission that we did together. And then you guys went off and did that, some other Python. Yes, sir?
Yeah, I forgot to open Zoom meetings and I have
So I just need to let you into Zoom.
Yeah.
Let me find it. There's a few. Get everybody in there. When you're looking at your Zoom screen, you should just be able to click on your picture or where the icon is where your picture would be to change your name to make it say dash remote if it needs to. So it's a pretty easy change. So looking at our code, the reason I wanted to bring up our code was last, let's see, Wednesday we kind of worked on stuff and had sort of a lab day mostly, other than getting things on CoLab. But I wanted to kind of revise our Python quick reference because we had started it, but there are a few things we've done in our code that we haven't added to our quick reference. So if you remember, mine was getting kind of colorful because I was trying to color code a couple of things. So the things that I have color coded right now are function calls, mostly to system functions, and then our programmer defined names. So even though they're kind of the same thing, we're defining function names in those two I have highlighted. Wanted to make sure that we know that we can actually change those. So let's look at our code. What else do we need to add here? If I look at our code, there's a few things, isn't there? First of all, that keyword global, we could put it like almost at the very top. I'm going to add a line at the very top. Let's cut this one and paste it. Oops. So I can have kind of an empty one and I'll just reuse it. So I want this global. I don't want it to be highlighted right now. And I'll just say this is a global variable. So we could say global space variable name. I feel like I fight with words so much, trying to get it to do stuff like this. I know it could be frustrating. But so then we have our global variable. And we've seen that we have to have it at the top. So before any modules, I'll call those subprograms. And then we have to list it again in subprogram that updates the variable. And you guys just jumped right on that and didn't seem to have any trouble. Now global is a little different because it's not really a function or a programmer defined name. The variable name is, so I could make it blue. I just don't want to get so many colors that we can't tell what's going on, which can happen. Where's my highlighting? There it is. I was like off on the wrong thing. But then the word global is a keyword. So I'm going to put that down here as another type. And let's make our keywords a different color. We'll do pink. That should be hugely blinding. Chartreuse, I guess. Now I could also say that death is a keyword. And then down here at the bottom, I see we were working on our global variable declaration, so I'm going to delete that because I have it in there twice. Anything else? I think we're in pretty good shape with what we have so far. In our input statement, I'm going to come down here after all of our highlighted things and do an example. So here, let's say we're going to say, I'll copy this input statement. Now, under this line of code, we could have lots and lots of things depending on what is confusing to us. Sales amount. This is the variable that will hold the input data. We could change that, right? That could be any variable name, whatever variable name we want to use. The equal is important. It says that we're assigning a value to the variable. And I'm going to put in parentheses that precedes, because we can't put them in any other order. And that's an error that sometimes beginning programmers try to make, is maybe putting the variable name that they want to assign the value to on the wrong side of the equal sign. So that equal sign is our assignment statement, and that's going to be real important in a second when we look at if statements. Next, that keyword int. Use the int function to cast the data as an integer. In our int function, the data that it's going to cast as an integer is being passed to it within parentheses, right? And in this example, that data is going to come from whatever the user types in the input statement. So we're stacking all sorts of things together here. So I'm going to put input, request, input from the user using the prompt. And again, the prompt is within parentheses. So sometimes when I'm reading a line of code, I'll almost read it backwards, because what I'm saying is, my prompt is, please enter the sales amount, which is going to cause the user to input data, which is going to be converted to an integer and stored in the sales amount variable. So notice how as you say that, you would almost say it backwards or inside out. Now, the reason I only have this one line of code as an example is because it has a lot of good stuff in it, and because the way to learn how to develop software is to notice the similarities. That, oh, this line of code is just like the next line of code that asks for input for something else. We just have a different variable name and a different prompt, and start seeing all those similarities. Okay, how do we feel? Is that we good with our quick reference for now? I'm going to minimize it because we're going to start looking at some if statements. Too much junk open. Here we go. Well, no. So I was thinking about, you know how as teachers always just like, oh, we have to talk about what we're going to do, and then we're going to do what we're going to do, and then if we have time, we'll talk about what we did. But today, sometimes us developers like to just do what we're going to do, right? And then talk about it later. So let's try that today, because if statements are really not a huge area of confusion, but we can talk about them so much that we can make them kind of confusing. So maybe if we just try some, let's see how it goes. Well, I have my Google Drive here, and this is our old one. I don't want to use it, so I'm going to close out of our Chapter 3 Colab notebook, and I'm going to create a new one for Chapter 4. So at your drive, and I'll give you a second to get there, we want to create a new one. Google Colaboratory. And it pops up with just the untitled. So let's give it a good name. And I'm just going to name it Chapter 4. In Chapter 4, we're going to be doing if statements and decision making. So if you want more information in your title, that's what we'll be working on. Somewhere, there it is, I have our Python Programming for Absolute Beginners book up. And we really will be looking more at our Prelude to Programming book. But like I said, I thought we should just jump right in and get started, and then we'll back up and look at how we would do these things in pseudocode. So in our Python beginner book, they say that if we're going to start doing some decision making, one application that works really well with that is the Guess My Number game. And that's true, it does work really well because we can prompt the user for input and then check to see if they give us the right number. But in order for us to figure out what number we want them to match, we need to be able to generate a random number, some sort of number to have them match. So in our chapter here, they're going to show us how to do that. Here's how our game is going to end up looking. On the console screen, we'll have some sort of message. I'm thinking of a number, try to guess it, and then we'll say lower or higher, try to give them some feedback as to which direction to go to get the number right. And we'll count how many tries it's taking them. So we're going to have a lot going on in this. When we're done, it'll be doing a lot more than just if statements, because it'll also be repeating and looping and running again until the user says that they're done. So we'll have a little bit going on in this application. So the first thing that they talk to us about is generating random numbers. We'll see this in our textbooks in different places, but let's talk about it real fast while we're here. These random numbers are not truly random. They're based on a formula. So they're kind of called pseudo-random, and they're usually good enough for most applications. They say don't try to start an online casino with it, so that's a little hint, hint. We don't want to, they're not that good, so we have to be really careful. If we needed truly random numbers, we would have to go look for a little bit more involved code. But we're going to look at, they generate random numbers based on the unpredictable process of radioactive decay, so some seriously random numbers. But when we're looking at these pseudo-random numbers, they're generated by this formula, and the formula has to have what's called a seed value, like a beginning number to generate random numbers. So we want to make that seed number as unique as possible. So what we usually use as programmers is the current date and time, and we would use time way up to the millisecond or beyond so that it's a very long number and very unique. Python takes care of that for us, so it'll go ahead and automatically generate that seed number for us and make it something that should be pretty unique. Here's the code we're going to use. We're going to make ours just a little bit different, but not too much. First, let's start with our comments. I'm going to drag this one out of the way. I've got to get a clicky thing. And I'm back at Colab, and I'm going to start with my first comment. Let's see, I'll do the multi-line. Sometimes this thing is doing different colors than what I'm used to. So my script here is, this is going to be the beginning, but we'll call this one generate random numbers. Make the developer you. Our date. And our purpose will be to generate random numbers in Python. Now the Python interpreter knows a lot about the abilities of Python, but it doesn't have all of the Python code included in it. Some Python code is included with Python in other source files, in other libraries. And we can say that we want access to those libraries so that we can use the code that's included in those libraries. And we do that with the import statement. And the random number library is a library that needs to be imported. So we'll just say import random. So all that does is tell Python, go out in the Python folder libraries and find this random file and make it part of my code. I want to be able to use the functions that it defines. Now we're going to pretend that we have two die, and we're going to generate random numbers between 1 and 6. So we'll say that die 1 is going to be equal to a random number, and we want it to be a random integer between 1 and 6. So let's take a look at that line of code. First of all, we're using the random library. We can tell because we have that same name, that word random there. And after the dot, whenever we have a library name like that, we'll follow it with a period. And after the dot will be the name of the function that we want to use from that random library. So we want to use the random int function, randint. If we searched for that online, we would see that it needs numbers, the beginning random number and the ending random number. Let's go search for it. I'm going to bring up a Google tab, and I'm going to search for Python randint. That's what it told me to type. And you'll see all sorts of responses. And the first ones I get are all from python.org. And they have really good documentation there. But if I go down a little ways, 3 or 4 lines down, I'm seeing W3 schools. And anything that's designed for education might be a little bit easier to understand. So I'll click on it. And sure enough, W3 schools has some great information. It says, this returns an integer number. And it says the parameters, which are the numbers we're going to pass within the parentheses, are the start and the stop. So we didn't really need to go look it up and find out any more about this function because our textbook isn't even asking us to at this point. It's just saying, type this code just like this. At this point, you're good. But we can always go out and find out more if we want to. So we've got our line of code there. We're saying, set up the first die. Now, what about the second one? If we're going to have 2 dice here, or 2 dies, how do we want to give it a face value? We'll use the random library again, but this time we'll try another function, the random range. And in the random range, we're saying what's the highest number that we want to be generated. So we would be generating anything in the range of beginning, which would be 1 to 6. So we come out with the same net effect. But when we're doing a random range, we're actually not going to return a number. We're not going to have a chance to return the ending number, the 6. The highest that this random range function would return is a 1, or I'm sorry, a 5. So we're going to add 1 so that we have a chance of that die being 6. And they just want you to be realizing that some of these built-in functions can give us different capabilities. Now let's calculate our total. What's the total of both die? Well, if we add them up, die 1 plus die 2. Now, whatever number was assigned to each of those will be added into our total. And then we're going to output some information. So our output is going to say, you rolled A. And then we're using the comma notice to concatenate. And I've said in our other book, it said you could use the plus sign. But Python, we're using a comma instead. And we'll get to where we're using the plus sign. But it's a little bit different. So my output is going to say, you rolled A, and then whatever number was on die 1. And then I want to add a little bit more. I want it to also say, and A. And then whatever die 2's value was. And finally, for a total of, my last output item is going to be the total. And then they really like for us to put the input statement at the end with 2 \n, press the enter key to exit. Okay, if you're set, you can try running it. I'm not going to run mine yet because I'm going to give everybody a chance to get it all. But if I try to run it, it's one thing that's nice about Colab, at least it doesn't go to that whole separate screen where you guys can't see my code anymore. Oh, it looks like it's working. Now, the reason that it continues running is because that last line of code we have is that input statement. So Colab is sitting there waiting for us to press enter or something. That's why it keeps running. But I've got my output here. I rolled a 5 and a 4 for a total of 9. If you run it again to get the same results, you shouldn't. Where's my, there it is. Run it again. This time, I got a 4 and a 2 for a total of 6. Is everybody getting good random values? Not getting the same thing over and over. That's what we want with our random number. Now I have a really cool website, if you can find it with me. Let's copy our code first. I'm going to start at the very bottom, and I'm just going to copy all of the lines of code. And I'm going to search for visualize Python. And that very first site that comes up that's called Python Tutor, that's the one we want. In the Python Tutor, you could actually use this site to write code. So if nothing is working, it's still cloud-based though. You can actually write code here. But we want to make sure we're writing Python code. So at the top, make sure the drop-down is set to Python. If you look at it, you'll see you can use this website for a lot of different types of code, which is kind of neat. But then in this code window, I'm just going to paste my code. Now I could change it here, whatever I wanted, but I wanted to show you how you can visualize the execution. So I'm going to click Visualize Execution. And it comes up with this totally separate screen here. So here's my code over here on the side. I could edit it if I wanted to. If I scoochie it over just a teeny bit, since you can't quite see the edge there, you'll see that there's a red arrow pointing to the line of code that's going to be executed if I click Next. So that red arrow is pointing to the line of code that's going to be run next. So I'll click Next. When I do that, it goes to the import statement, not too exciting. So I'll click Next again. Oh, it did something. Over here on the side, we don't really know a lot, but it shows it's got this random thing copied in. So something happened. I'm going to click Next again. Here's where things start getting interesting for us. Now we see that a variable named die1 was allocated, and it has a value of 4. So that line of code here, line 11, allocated our die1 variable and filled it with that random integer value. It ended up with 4. Now if I click Next again, I'm going to run the line of code that's going to allocate die2. So there's my die2. Oh, it also got a 4. Now what's going to happen on line 14? I should see my total variable get allocated, and it should end up with a value of 8, right? Because it's going to add up those other 2. There it is. So I see it. Now if I click Next, I should see my print output, and it's going to show up here. There it is. And then I've got my line of code that's waiting here for me to press Enter to end it. Now I could do things differently if I wanted to. I could, like I said, edit this code. So let's change it from a 6 to a 24. And if I visualize execution, it's going to start out in the same place. It's going to import the random library. My first die value is now 13, so I can see it adjusted. My next one, 14, my total, and then my print output.
Got a quick question. Like everyone around me is doing the same exact numbers as you.
Oh, really?
Yeah, I think we're all doing the same numbers.
That's neat, isn't it?
I'm just kind of curious, like, why is that happening?
Well, it could be a lot of different reasons, and I couldn't tell you for sure because I didn't write the website code.
Okay.
But my thinking would be that they're using one random number generator and we're all sharing it, and that would be the reasonable way for them to do things resource-wise on their website. And then that way, anybody who asks for a random number is going to get this one random number generator that they have loaded into memory, instead of each of us having our own random number generator loaded into memory on their server, if that makes sense. But it is an issue with random numbers, and that's what we can run into, where we run into some not randomness that we have to be concerned with. So that's very interesting. And I'm also noticing that, like, with die1 and die2, I'm ending up with the same number. It's the +1 that's changing them to not be the same. So good observation. So we can't be sure what they're doing on their website. Now, if we go back to Colab, we could actually have the same thing happen because we're all using Google's structure, right? So we're not really running our own instances of Python. We don't know necessarily how they have it set up. So we could end up with the same random numbers here too. Are we? I hope not, because it would mess us up for the semester if we were. We're getting different ones here. Good. Because the way Colab is set up, we could end up with that same thing. All right. That looks good. Well, let's put a section heading on this thing. So how do we do that? Somewhere over here, I clicked on the table of contents, and then I can click section. And I'm going to type my new section. You can type it over here, and it'll show up on the other side. But let's make this say random number. And then we should be able to move this thing up above our code. Did you get it?
Actually, no, I have to look at I accidentally made a few other lines.
That's okay. They won't hurt anything, but you can delete them if they're.
I'm just trying to figure out how to delete them.
You should be able to use this tool here. So how you look at it, it's sort of like a Google form, which you might not have messed with. But over here, since I have this section header selected, notice how it's kind of raised. The tool set here is applying to that.
Okay, all right.
So I can click delete, get rid of it.
Thank you, I appreciate that.
Sure, see how they fit together. All right, so now we got this random number working. We don't have any functions or subprograms in this program, but that's okay. I mean, we just have a little bit of code here to give us a sample of how to do this. Now, if you're looking in your textbook, the Python book, they will get in depth for you a little bit more about the modules that we used. And then we're finally to using the if statement. And we have a separate program for this. They want us to try a program that's a little password program. Now, an if statement, to some people that have already been coding and working on things, it's just second nature. It doesn't seem like anything difficult. To others, though, we have to really think about what is an if statement. Well, it is something where in our algorithm, we have some sort of decision to make. So if you guys remember way back to that very first week, and I told you my algorithm about getting to my neighborhood, and I told you, right, that I had that crazy guy that one semester, and before that I used to tell people how to get closer to my house, and then he knew how to get to my house. And he got crazy because, just to tell you a story, because I showed him how to set up his OTC email on his phone, and then he came in and he said that as soon as he set up his OTC email on his phone copied everything off his computer and sent it all to OTC. So if you hear of any students saying things like that, let me know and then stay away from them. I was like, sir, it can't copy all of your computer stuff to OTC server, and they don't care about it, but he was pretty sure it had. So anyways, that's why, as a side, I don't tell you how to get to my house, but I could tell you that maybe you might have some decisions to make on the way there, right? So what if you were heading out to my neighborhood and there was a giant traffic jam? Your brain would look at that and you would make a logical decision, a logical choice, right? You would say, I can either sit here in this traffic for however long it takes for it to open up, or I could go a different way. I could turn left, take an alternate route, and see where the path takes me, or my phone takes me, either way. But if I did that, I would be making a decision, and I would be altering the flow of the algorithm. And that's exactly what an if statement does, is it just makes a decision, and based on that decision, we can alter the flow of our code. So this application that they want us to create here is very, very quick. It says a couple of messages, and then it asks for a password. And if we type in the right password, it gives us the message access granted. So let's type this one up. So the first thing I want to do is add a section. And I'm going to make this section be, what did they call this thing? Password. And then I got to move my section down. Now, after my password section, I want to create a new section of code. So I'll just click the plus code. And that starts a new code section down there. Take it outside if you need to use it. Okay, so first of all, they have some comments, and they don't have their comments as good as we do. We'll do better. So we'll say our script here is the password. And our purpose really is to try an if statement. Now we have a nice welcome message. Let me finish up our header comments. And then we'll display our nice welcome message. Print, welcome to Security Systems Inc. Actually, it's System Security. And then they have their logo. They say -- where security is our middle name, \n to get a new line. So it was important I fixed that name, wasn't it? Since that's their logo, where security is our middle name. Now we're going to actually create a variable named password, and we're going to use the input statement to load it. So our prompt is going to say, enter your password, space. And then if the password variable equals the word secret, I can type, we're going to print access granted. And then let's talk about our if statements. Now, if I want to put some additional comments, I can kind of put some comments where we might put functions. So prompt for input password. And then our if statement, check to see if password is correct. Now with our if statement, we haven't talked about them at all. So let's notice a couple of things first off. If it's a keyword, that's why it's turning the chartreuse color. It's not a variable name or a function name, it's just something special. Whenever we have an if statement, we're going to use special comparison operators to determine what we're checking. In this case, we're checking for equality. We want to see if the variable password is equal to this string secret. When we're checking for equality, we use 2 equal signs together. So notice that's different than just using 1 equal sign to assign a value. At the end of our if statement then, we have a colon. And we have a colon because the if statement could have a body. It could have a whole bunch of things that only happens if the if statement is true. In this case, the only thing that's going to happen if the if statement is true is we're going to print out this message, access granted. What's going to happen if the if statement is not true? Nothing, right? It's just going to continue on. It's not going to do this print statement. It's going to bypass it because our if statement is not true. So let's try it. Here's our little heading. Welcome to System Security Inc., where security is our middle name. Enter your password. I'm going to try to enter my password correctly. S-E-C-R-E-T. Of course, we're not doing anything to hide it, so we can tell. Now, when we press enter, if we got it typed right, we should see that message, access granted. Now, what happens if we type it incorrectly? Let's try it. Should be nothing, yeah. If I just press enter, we get nothing. Good, so let's copy and paste that code. Copy. And I want to go back to our Python code visualizer site that I probably closed.
I actually had an issue on mine.
Did you?
Yes, actually. It's probably something small.
Uh-huh.
It's nothing major, but I'm trying to see if I spelled anything wrong. Can I share?
Sure.
All right.
Let me unshare.
Okay.
All right, go for it.
Let's maximize this. Yeah, here's my code right here. I'm trying to figure out what it is.
Can you zoom in a little bit? It looks good.
But like when I type in secret, I just, oh, okay, never mind.
I think you're good.
It didn't work last time.
It didn't work before?
Capitalized last time.
Oh, okay.
That was down, my fault.
Got it, yay. All right, I'm gonna share my screen again. And I'm back at the visualizer site. And I have to actually click edit this code to go back to that screen where I can select it and then paste the code I copied. I just want to try the if statement in this visualizer site because it's kind of interesting how it shows you that it's bypassing. So let's visualize. I'm sitting here waiting to display the welcome message, so I'll click next. Next, there's our first welcome message, our second welcome message. Now, here's our password prompt. I'll type something in, secret, submit. Now it's at our if statement. So if I click next, it's going to evaluate the condition. And now we can see that it's going to run the print statement. And there's our output. Now, if we start the whole thing over, and this time, type in something else. I didn't type anything. So I should see it bypass that statement. Whoops, I did something wrong. It's not prompting me for input again.
Can you refresh the page?
Yeah, it's only gave me the one time.
Yeah.
Meanie. bad password. And then I should see it, skip past that print statement. Now it'll have more meaning if we add some more code, but it makes it more complicated too. So all of our different angles here. Okay, so our first if statement. Now some things about that if statement. That if statement is a single alternative. That means it was only going to do one thing. If the if statement is true, it'll do the code that's in the if statement body. That's it. That's the only alternative we have for that if statement. So let's look at if statements overall. I'm going to go back to Canvas. And we have a couple of different PowerPoints for if statements. We have the one from the textbook, but let's look at this selection statements extra first. Okay, we're going to look at selection statements. And when I started teaching here, that was the first time I'd ever heard of an if statement being called a selection statement. And now I see it everywhere. It's kind of a new thing. I don't know, 10 years old or so, sort of new. But it means selection statement means select which code to run. So when I'm doing an if statement, I can decide which code should be executed based on the condition that I'm checking for in the if statement. So that should hopefully make more sense. First, let's look at a flow chart. Whenever I'm working with an if statement, then I'm going to see the decision diamond. The decision diamond tells me right away, oh, there's an if statement or some sort of while loop that requires an if type condition. When I'm working with an if statement, I always have to have a true or a false branch or a yes or a no. Something that's labeled that says which direction to go based on the result of the comparison. When we're working with an if statement, what's important to us is the condition. What are we testing? That's our test condition. Our test condition is going to return either true or false. So if I'm looking at traffic, I could say, is the stoplight red? That would give me a true or a false condition. Is the stoplight green? That's going to be true or false. Is that car speeding? True or false? Anything like that that results in something that's true or false, I can create a test condition out of it. These are the kinds of operators I have to determine my condition. I can say, is this thing less than some other thing? Is it less than or equal to some other thing? Greater than, equal to, or not equal to? So those are my relational operators. They tell us what kind of relation we're looking for between the different things in our conditions. And our condition has to have two sides, two operands, right? The left side and the right side. So I have to say, is the light green? Is the light yellow? I have to have both sides, the thing and what I want to compare it to. The operand, both sides, could be variables. They could be literal values like a string, like we just did with our password. They could be a number, like the number 42, anything we want. So let's think about this pseudocode here. Here we have an algorithm that looks at a row number. And we're looking at our classroom here, and we've declared our row number is an integer. we've assigned a value of 2 to our row number. This could have happened a long time ago. We just know it's happened. Now we're in an if statement. And our if statement is saying, if row number is 2, then, right, row number 2, please stand. Let's have them raise their hand. Where's row number 2? Are you guys row number 2? Yeah, raise your hand or else I'll make you stand up. Oh, uh-oh, gonna have to stand up. We're not all raising our hands. Row number 2, raise your hand. Good job. All right, everybody else, are you affected at all? No, not one iota, right? Is row number 2 affected? Yes, they are the only ones because that's what we're looking for in our if statement. Single selection, they're the only ones that get affected at all. All the rest of us, just wait till they're done and then all of us can say thank you because we're all affected there. All right, so when we looked at that equal comparison, these two things are exactly the same, right? If row number equals 2 or if 2 equals row number. Doesn't matter what order they're in, right? Because they're equalitative. Whenever we're looking at equality, we'll have the same results. Programmers prefer this type of setup. Variable, some sort of constant after. That's just a preference though. So the if statement will be the same either way. What about if we're working with a less than condition? Here we'll have fewer people raise their hand, right? In this case, we've assigned a value of 1 to our row number. Oops, I'm sorry. We're looking at row number 1. In our if statement, we say if row number is less than 2. So row number 1 should raise their hands, right? Do it, they do it, they do it, yay. And we've got row number 1, good job. And the rest of us, again, are we affected? No, not at all. It's only those ones that have that row number that's less than 2. So we could use that less than operator in our comparison. Notice that the row number less than 2 part is the test condition. Everything else around it is irrelevant. This test condition is the same in pseudocode, on a flowchart, in Raptor, or in Python, right? The keywords around it, if, then, or if, and the colon, might be a little different, but the actual condition part, the part in green, is the same. That's the part that we're concerned about, row number less than 2. The less than, in that case, is our relational operator. Now, looking at our order here, if we switched this one, would we end up with the same results? If row number less than 2, is that the same as saying if 2 less than row number? No, it's not, is it? So we have to be careful because we don't have that same equality of operands when we're working with a less than or a greater than as we do with the equal sign. So someone could mess up the if statement really bad if they're not paying attention when they want to put things in the right order. What about this one? Here we're looking at row number 3 or 4, and we say if row number is greater than 2, let's turn around and make sure they're all raising their hand. Rows 3 and 4. Okay, so this time we said greater than 2. We actually got 2 rows, didn't we? But the rest of you weren't affected still. So notice how this if statement works. It doesn't have to do something every time we run it, right? It only does something if the data is applicable. Now, looking at this condition here, we have 2 operands, left operand, right operand, conditional. And all those keywords in your head. Okay, so whenever we're looking at an if statement with pseudocode, we're going to use the keywords if, then, with the condition in between. We're going to put all of the code that we want to be in that if statement body, all the code we want that executes if that if statement is true, indented under that if statement. And then we're going to have an end if when we're done. So if I want all of the people in this row to stand up, turn sideways, jump 20 times, all of those things would be indented under this if statement before I got to the end if. everything that I wanted them to do. Now, when we're working with our flowchart again, don't forget the orders, the arrowheads show the direction, so they matter a lot. They show our logic flow. All right, so the if statement we saw earlier is a single alternative. We could only do one thing. What if we want to be able to have alternatives besides just the one when the condition is true? What if we want to check other things? Well, we would add an else. Here's when. In this case, we have a flowchart over here and our pseudocode over here. We're declaring a variable named brown hair, and it's a Boolean. It can only have values of true or false. Now, each of you, based on your hair color, will assign yourself a value for your brown hair variable. Is it true for you or is it false for you? Now, if you have brown hair, you can just raise your hand instead of standing. One semester is every brown hair people, raise your hands. Yay. Now, if our brown haired people are raising their hands, our other people could do something else. Like in this case, we just have them say thank you, and our brown haired people don't have to. That didn't visualize very good. We should make them have to, I don't know, shake their head or do something weird. Here, let's try it. We'll make them do something else. What if we have multiple selections? This is what we need. We have more than 2 colors of hair. So let's try it. Here's a good one. We have hair color instead of just a Boolean. We've made it a switch. And now we're saying, if you have brown hair, give yourself a value of 1 for hair color. If you have black hair, give yourself a value of 2. If you have other color hair, give yourself a value of 3. So now I want you guys to do these things. So if you gave yourself hair color 1, your brown hair, please stand. If your hair color is 2 and you're black haired, please turn left. We need our brown haired people to stand up. Stand up, brown haired people. Black haired people, turn to the left. So just roll your chair left ways. We got some turning left. Now, all of the other hair colored people, please turn your chair to the right. Okay, now look around the room without rearranging yourself. Notice how everybody has some sort of effect one way or the other, but nobody's affected more than once, right? You had to have just one choice. You can sit back down, thank you. These things don't mean much to you when you're listening to me going, what is she talking about? But these are all things that people have trouble with if statements and trying to understand why they do things that they do. Here's a flowchart for that one. We had a bunch of if statements sort of all combined. So our flowchart would have kind of if statements going across. So we would say if hair color is 1, we did the brown hair, please stand. Otherwise, if it's 2, we did the black hair, please turn left. Otherwise, if it's 3, we did the turn right. If none of them were selected, there was a problem, right? Please pick. So that's our flowchart. So that's multiple selections. In our textbook, The Prelude to Programming, they tell you about a programming tool called a select case. We don't have this in Python. So this is one of the areas that's hard to remember in our class because our Prelude to Programming book wants you to know about this select case statement. But Python says, you don't need to know about it. You have to because of your book. So this is what a select case statement would look like. Instead of saying if hair color, we would say select case of hair color. In the case it's 1, do these things. In the case it's 2, do these. In the case it's 3, do those. I'm glad they did print 150 pages. Otherwise, do some other stuff. So the select case statement is just like a multiple select if statement. It's just a little bit different of a syntax. So here's a flowchart for that. You can see how the select case statement is more efficient because we only have to check the value of our hair color 1 time. Based on that result then, we follow the appropriate path through the right case statement. So I wish we could do this in Python, but we can't. So just keep it in the back of your mind that it's something that you can do in other languages. Now, sometimes just one thing is not enough. Some things we need complex conditions where we say, if your hair color is brown and your row number is 2, you might have to do some special things. Or maybe we want an or condition where we're saying, if your hair color is brown or your hair color is black, I want you to do some special things. Or maybe I want everything but a certain option. So maybe I want everybody that's not got a hair color of brown. So all of these logical operators, the and, or, and not, let me combine my conditions so that I can make them even more complicated. When I do that, I need a way to keep track of everything. And as a programmer, I can do that with a truth table. Now, when I look at this at first, it doesn't seem to be saying much of anything, but it's actually saying quite a bit. What it's saying is, let's say I have 2 variables, one named X and one named Y. They're Booleans, so they can only have a value of true or false. Then I have an if statement saying if X or Y. So that if statement would be true if X is true or if Y is true, right? So if X is true, this condition X or Y would be true. If Y is true, the X or Y condition would be true. If X is true and Y is false, this or condition would still be true, right? Because one side of it is true. If they're both false, however, finally this or condition would be false. That's the only way. Now, what about if we had an if statement where we said if X and Y? So instead of using or, we're using and. Now, in that case, if I have true and true, it'll be true, but none of the others. Because my and condition says this if statement will only be true if this half is true and this half is true. Now, if I use the alternative not, and I say not X, that basically turns a negative on the whole works. So if X were true, not X would be false. If X is false, not X is true. So the not keyword just basically turns everything on its ear and flips it around backwards. So we should not use not, right? We should not use not. So the only reason we would use not is if it was extremely logical in the situation we were in. Once in a while it is. But in general, we have to stay away from it because it can be kind of confusing. Okay, awesome. So now we know a little bit about if statements. Let's update our quick reference. I'm going to put this down after our function stuff. If, get rid of my highlighting here. So we could say if X equals Y colon. So if a condition is true, run the body. Now remember, the body is all the indented code after the colon. Good, good. So our if statement is not hard. We just have to keep track of what's going on with it. So let's update our password program real quick, and then we'll call it some lab time. Now in Collab, we left off here with our password program right here at the if statement. So we know that if we type the password wrong, nothing happens. And that wasn't very nice. It would be nice if we gave our users an error instead of just not having anything happen. So let's do an else clause. Now, when I press enter, I am moved down to a new line. I'm going to put another print statement. Congratulations. Just because I want you guys to know that there could be more than one line of code in that body. You've done that to people before where there's just one line and then it can be a little confusing. So if they get their password right, we're going to say access granted, congratulations. Now, if they get it wrong, we're going to do whatever comes after the else. So to put my else clause, I back tabbed because I don't want it to be indented. So as soon as I outdented or back tabbed, Python says, oh, that's the end of that if statement body because we're no longer indented. All right, so as soon as it hits that else being in column 1, it knows that's the end of the if statement. But the else is going to have a body itself, so it ends with a colon. Now in our else clause, when we press enter, then we should be indented, and we'll print access denied. And then let's put another print statement. We'll just say rejected. Good, so we're not doing anything like super fancy, just changing what message we're going to print out depending on whether they type that correctly or not. So let's try running it. So I'll put in a bad one. And we should see our else message. Now, if I run it again and put in that word secret, I should still see my access granted, congratulations message. Is it working? Any questions? Everybody's got it okay? Good. Let's stop there today. And next time we'll do the ELIF and finish out our chapter. But what do you need to do? We have quite a bit for this week. So I want to stop and give you some lab time. It's not a lot. But Our chapter 4 review questions should be getting to be a little bit fewer than the review questions you've been doing before. The Code Academy Unit 3 stuff. Everybody found the Code Academy? I know I got a few emails. It is the outdated stuff. That's how Code Academy decided to make money, you know. They said, well, let's quit doing this out-of-date Python thing and we'll charge everybody. So that was their first money-making module, was the Python 3 stuff. So it makes it a little bit hard on you guys. Just remember, the only difference is the print statement with no parentheses in the old Code Academy release, parentheses in our release. Now, when you get into Unit 3, they're talking about if statements. And they're going to give you some if statements, some conditions that are like, I think that it has some sort of keyboard calisthenics or something. I used to have this student that, have you ever seen people that play DDR for your fingers? They have this DDR game for typists to see how fast you can type. And he was one of those. He loved playing that. Well, anyways, that's how this Unit 3 for conditionals feels in Code Academy. Like it's just trying to make you do all these calisthenics with your fingers to type some really weird stuff. You can copy and paste those conditions in Code Academy, okay? So over here on the side, when it's saying make this if statement be 75 characters long, just copy it and paste it into the code window so that you don't have to type all that. Because I think you guys are really, really good typists already. It's just the logic that I want you to understand. So type it if you need to, but in general, copy and paste. Now, you probably already have enough information in your head to do this positive, negative number program, but you should do the chapter 4 review questions and the Code Academy stuff first and save the program until a little bit later, until after you've done those other things. So when I'm looking at stuff and deciding how much work to give you guys, it's kind of difficult because some people have so much experience that they can just fly through some of our early stuff. And when you're brand new, it is not that way. So just remember, you know, to take it at your pace and think about how long it's going to take you, and don't worry about how long it takes anybody else, because everybody's at a different place here getting started. Even though we're 6 weeks into our class, we still have people that have a lot more experience than others. So let's stop there and have some lab time. Any questions before we do that? Everybody's good? All right. I'm going to turn this off then. You are welcome to stay here and work online.